So today we're going to be looking at section 4.3, which talks about the graphs of y equals tangent of x and y equals cotangent of x. So I want to just start with y equals tangent of x. So I'm going to be graphing that. So here's my x-axis, that's where I'm recording my angle. And here's my y-axis, that's where I'm recording the trig ratio I get from the tangent function. Okay. And I'm just going to draw myself my unit circle. I'm going to label there those axes as capital X, capital Y, so as not to confuse them with the x and y values that are my angle and my tangent of my angle. And I'm just going to remind myself that if I have an angle that I call little x, it intersects the circle at a point capital X, capital Y, okay? And that the definition of tangent of x is that it's the ratio of that capital Y over that capital X value. Okay. Now, I'm just going to go around the circle the same way we did with sine and cosine. And I'm going to just start by marking off what happens at my quadrantal angles. So 0 and pi over 2 and pi, and 3 pi over 2, and 2 pi. Okay. So, might be helpful to just indicate the coordinates of my points. This is 1, 0, this is 0, 1, negative 1, 0, 0, and negative 1. Okay, so remember that in this picture we're representing our angle rotationally. In this picture we're representing our angle as a point on the horizontal axis. So that moving to the right here corresponds to rotating around counterclockwise in this picture. Okay. So when my angle is 0, we're here. Y over x will be 0 over 1, so we're going to have a point at 0. But now something interesting happens at pi over 2, because if I tried to plug into my formula, I would have a 1 on top and a 0 on bottom. Don't write it. Okay. This is completely undefined. I don't want to see it on your page. A lot of people have already lost points for writing that. Even if you tell me it's undefined, I don't want to see it. If you write it, cross it out. Okay. So I know that there's not going to be a point on the graph anywhere where x is equal to pi over 2. But I want to figure out what happens close to there. So if I'm close to this point, my capital Y value is close to 1. My capital X value is just really, really small. Now what happens when I divide by something really, really small is I get something really, really big. Think of like 1 divided by 1/1,000,000th. Well, dividing by 1/1,000,000th is the same as multiplying by a billion. So I'm going to get something big. So as we get closer and closer to pi over 2, tangent gets really, really big. Sometimes big and positive in quadrant 1, sometimes big and negative in quadrant 2. But the way I'm going to indicate that is by drawing this dotted line here, which we say is a vertical asymptote. Asymptote. There we go. Okay. Now, when I'm drawing my graph, as I approach the asymptote, I've got to either be going up towards infinity or down going towards negative infinity. And I'll have to figure out which that is. Okay. Let's just keep going around the circle though. Okay. At pi, 0 over negative 1 would just be 0. At 3 pi over 2, I have the same problem. My capital Y is close to negative 1, but my capital X is 0. I cannot divide by that. But close to there, I'll be dividing by something super, super small. So we'll have an asymptote. Okay. And then at 2 pi, we're right back to where we started, so we'll be back at 0. Now, this is the first trig function we've seen where we've got these vertical asymptotes. There's a nice rule for graphing things with vertical asymptotes, which is start and end at an asymptote. So I can see with my quadrantal angles, we just alternate 0, asymptote, 0, asymptote, 0. So what I'm going to do is I'm just going to extend on either side so that I can start and end at an asymptote. My next quadrantal angle to the left here would be negative pi over 2. And if I extend over here, didn't leave even enough space, I'd be at 5 pi over 2. That's going to also be a vertical asymptote. Okay, so if we take a look at this now, I've got some information about what the graph is going to look like, but I'd kind of like to see what happens in between these zeros and these asymptotes. So I'm going to remind us that these intervals correspond to quadrants when we represent our angle rotationally. So from 0 to pi over 2, that corresponds to quadrant 1, and then this is 2, 3, 4, and then back to 1. Once we pass 2 pi and we keep rotating, we're in quadrant 1 again. Over here, between negative pi over 2 and 0, that's quadrant 4 again. So I'm going to now use my knowledge of the quadrants to see what's happening. So in this interval, I know I'm 0 here. I know I have to get big as I move to the right, but I don't know whether I'm going up or down, except that we're in quadrant 1. And in quadrant 1, I know that tangent is positive, so it must go up. Looking here in quadrant 2, we're 0 here. Working backwards, I'm going to be drawing things moving to the left, so I'm drawing it backwards. I know I've got to either go up towards infinity or down towards negative infinity, but I know in quadrant 2 tangent is negative. So working to the left, I'm going to go down towards negative infinity. One important thing, as I drew it, I was going down as I went to the left. Reading functions, we always read left to right. This function is actually increasing as we go left to right. In quadrant 3, tangent is positive, so we'll go off to positive infinity. In quadrant 4, it's negative. And then I'd extended things. So in quadrant 1, it's positive, and in quadrant 4, negative. Okay. So that's what we get for our graph of tangent. Now what's kind of interesting is this is an interval of length 3 pi. I've graphed 3 periods because I can see it's doing the same thing again and again and again. So the period of tangent is actually pi. That's the length of the interval that it takes for us to go through just one cycle of the tangent function. Okay. So we don't have to go all the way around the circle the way we did with sine or cosine before we start repeating a pattern. Tangent repeats its pattern over every interval of length pi. Okay. You might ask what the amplitude is. There isn't any. Amplitude is supposed to be the vertical distance between a high point and a midpoint. There's no high point. It goes off to infinity. So the concept of amplitude only makes sense for sine and cosine, but the concept of the period is going to make sense for all of the trig functions. Okay. Now, when you are graphing a tangent function, make sure you read the directions carefully. For sine and cosine, I'll usually say graph at least 1 period. So if you wanted to draw 2 periods or 3 periods, that's fine, as long as you've got arrows to indicate that it keeps going on forever and ever. Okay. With tangent, I want you to follow the rule that you start and end with an asymptote. So I would probably say draw exactly 2 periods, something like that. In which case, my graph is too much. I've graphed 3 periods. If the directions had said to graph just 2 periods, then I'd maybe start at negative pi over 2 and go to 3 pi over 2. Or I could have started at pi over 2 and gone to 5 pi over 2. I can pick which 2 I'm going to draw, but I want to make sure that I follow those directions. Okay. I can improve upon my graph just a little bit, and that's going to be important as we move on to transformations. Right now, just plotting the quadrantal angles, I end up with just plotting 1 point in between each set of asymptotes. We can improve upon that a little bit. If we view this as our starting and our ending point, I'd kind of like to have 3 points in there. So at least for this one, I'm going to plot a couple of extra points. At pi over 4, which is halfway between 0 and pi over 2, I know my tangent would be 1. And then at negative pi over 4, I know that my tangent is negative 1. Okay. And then I'd have basically the same thing over here. These angles would be 3 pi over 4 and 5 pi over 4. So by plotting those points, that helps me to see a little bit just exactly how steep, how quickly it's going off to infinity or negative infinity. So again, read the directions carefully, but I will probably ask you to draw exactly some number of periods, often 2, and I will probably say to label at least 3 points per period. So not just your quadrantal angles, but if you go with the angles whose reference angle is pi over 4, those are very nice choices. Oh, before I stop the video, the next thing we're going to do is graph cotangent. But what I want you to do is see if you can follow the thought process that we went through here to see if you can come up with the graph of cotangent before you turn on the second video. On the second video, I'll have it already up on the screen so that you can check your work.